Hello everyone. So in our last class, we discussed about the analysis stuff for HR employee attrition data set, and we did a lot of data visualization to get the understanding what is happening there with the data. So that was based off the employee rating and basically the department or the travel. There are so many things that I have covered. So I'll suggest you to go through with the previous video so that you can get the idea what is happening in that data. And to go through further, I have in today's video, we are going to create a model and to predict, we will be doing a prediction based on the final features that we have created in our last video. So you just go through with that, and let me start with today with the model modeling part, right? So here we have started with the model preprocessing because we have some unlabeled column as well that we need to label. So I have just imported the required packages, and these are the columns that are available with us. Let me do a head as well so that you can see the value of each and every column here. So here it is. Let me pass only two. So you see that we have few columns where we have basically the unlabeled data, like we have the attrition, that we have business travel, we have department as well, the education field, the gender, and I think some more are there. Oh yes, the job role. This is kind of sales executive, research scientist and all. We have marital status and the overtime as a binary value. So we are going to, these were the final features that we have included. And now whatever the column we have as unlabeled, we are going to label those using label encoder. So I have what I did, I have, rather than passing all the columns line by line to apply a label encoder, I just put that into a for loop to do that job in one go. So to do it, I have created a label encoder object. I've already imported this, the label encoder. L is the object. And I have put it all the required columns where I need to apply the attrition, where I need to apply the basically the label encoder into a list. So that is a categorical variable list. Here I have put it all the columns, and now I'm going to apply a for loop, and under that for loop, I'll apply a fit transform to each and every column that we have under data. So what this loop is going to do in categorical variable, once that loop will start, we have first value attrition. Then for this data, it will select the attrition column, and then it will apply fit transform and all. So once it is done, I have put it the data dot head as well. Okay, let me run that categorical variable as well. So here we see that all columns has been labeled now. So you will see that we don't have any unlabeled column with us now. So what are my input features apart from the attrition that I need to predict? I have all the, I'm going to use all the columns as our input features. So what I did, I have created two variables here, the target and train. So the target is the one you call it is either a dependent variable or a target column. So target I've selected as attrition, and apart from attrition, I have put it each and everything under training data. So I just drop attrition to the column axis and then everything there in train. So I just did it. My target and train is available. In case you want, I can showcase you the value to these two target dot head one. So here it goes. So that is the attrition. We have the binary value you can see here under this attrition column. And for the training, we have all the columns apart from the attrition. So that is head. Let me pass one on this. So we see that all the columns are here. Perfect. So our input and target features are available. So we are going to create a classification, apply a classification algorithm. So I have selected a few algorithms like logistic regression, SPM classifier, k-nearest neighbor, decision tree, and k-means clustering. So I'm directly going to apply those. So in case you need it, I can create a separate video to understand the background or the maths behind each and every algorithm. So what I did, I have created a to list train accuracy and test accuracy for all the models that I'm going to apply. So what I'm going to do, I'm going to create a function, and using that function, it will give train and test accuracy for each classifier. So I can get it in one go after running this particular function. So what this function will do, I'll be passing my train and test to it as input, and in train error, I did the Y train. I have created this two variables here, and then sum of those, and then I have divided with the length of Y train and into the 100. So this is basically the accuracy percentage what we are going to have here, right? And the same for the test. And then I have appended that value to the list that I have created here. And then I formatted it. So I'm going to run this and this function as well. So I'll use that function later. So I'll be using a train test split to apply to my train and target column that I have created. So this is, I have used the 75 and 25 ratio. So that's why I've used the test size as 25. You can put train size or test size, either one. So that's how I've created the training and test variable for both. So here it goes. Then I'll be applying the algorithms one by one. So here what I did in this block of code, I've imported the logistic regression from masculine linear model. Then I have created the object here, that logistic regression, and the log reg is the object. Into that, I'm going to fit my training data. So here I fit that, and then I have used a predict to pass the training data, and I have created a variable train predict, and the same I did for the testing data, so that I can check the accuracy as well. And here what I did in the object that I have created into the logistic regression, I passed the train into the predict function. So here I'll be having the predict probability and the predicted value. So where I'll be having the y prop greater than 0.5, I'll be putting that as 1, or else everything will goes as 0. So this is how I'm going to pass my train predict and test predict, which I have created using a predict function, to this function that I have created to get the accuracy for the training and testing both the data. So here I did it, and this threshold that you can change, I have taken the 50, but in case you want the higher threshold, so you can change that value. So I have just used the general threshold. So here it goes. So here you see that the accuracy for the training data is 83 and the test data is 86. So this is what the accuracy we received from this logistic regression. Now I'm going to use this SVM classifier. So I just imported SVM from sklearn. Then from SVM, I have used SVC because the classifier that I'm going to use. And then I have put it into the SVM object that I have created from here, the training data for X and Y both. And then the same I did for the train and test, to create two variables and then pass into that function, so that here only I can get the accuracy for SVM classifier as well. So that is 82 for the training and 86 for the test data. Exactly the same I did for k-nearest neighbor classifier. So I imported the neighbors, and then I have mentioned the number of neighbors here, and into the neighbors.k nearest neighbor classifier, I passed that value that I have passed, and the weight I have taken as a distance, and then I put it the training and X-train and Y-train data to the fit method to create to fit those training data into the classifier. And then I have pass the training and test data to the predict function and created train predict and test predict variable, and apply train predict and test predicted to the train test error function that I have created here only, so that I can get the in the same block of code. What I'm doing, I'm importing the required classifier, I'm fitting that the training data to that, and then predicting for train and test both, and then passing the value of those predicted train and test variable into that function that I have created to get the accuracy. So this is what I'm doing here for each and every classifier. So here see that for the training it is 100% and for the test it is 86. And now let's go to the decision tree classifier. So for the decision tree classifier as well, here I have imported the tree from sklearn. Then decision tree classifier I used to create object as DEC and then fit the training data for train and X train and Y train and created predict the variable for training and testing both data and passed into the function. So here see that we have good training accuracy, but test accuracy is less here for the decision tree classifier. Now let's go to the k-means clustering as well, and the cluster that I have used too. So did the same here, imported the k-means from the sklearn cluster and number of clustered I have passed and fit the data and the predict the training and test data into the predict function and created the variable and applied. And here is the output for this k-means clustering. So it's quite less comparatively to the other classifiers. So what I did here, I have created a data frame here with test accuracy and the train accuracy as 2 columns. And in the index, I have passed the models so that I can put that under results. So all the training and all the train and test accuracy there corresponds to each and every classifier that I have used. So we see here, we have basically the highest test accuracy for the logistic regression. Yes, and the minimum is for k-means clustering, and for the training, the highest for the KNN and the decision tree. So this is how, rather than doing the same thing for each and every algorithm, that's why we try to automate this part, and here is the outcome. So that's the standard way. Further, you can fine tune your model and to improve the accuracy, to change the set, and further you can, there is a lot of option to improve this model, the modeling part further, but this is just a general way to do it. I hope it's clear to everyone. So that's it for today. I'll come up with some interesting stuff to with my next video. Thank you everyone. Take care. Bye bye.